We are about to get started, and let's wait for a few more minutes for other folks to join in. But until then, let's do a quick check as to how we're doing today. Quick note before we get started, I have shared the link to our check-in and registration page to go ahead and check in to get your community points. If you all want, I'm happy to share it again. Let me know. But yeah, let's wait for another 5 minutes before we start. I can already see the chat is nice and active, which is great because I like interactive hackers. I talk a lot and I like being interrupted and being told that, hey, move on. And yesterday I had some great hackers who joined in and asked me to do just that. So I'm looking forward to all of you all interacting with me. Today is again going to be a pretty simple session. Y'all don't need to have attended the last session to keep up. We're going to understand how to read a data sheet and see why it's so important. Me and Aishika did a stream recently on GitHub Education where we shared enough stories as to why data sheets are very important. But yes, we will go through an entire data sheet together, and we will also set up your projects before we actually start writing code. In case you weren't there in the last session, we covered short C crash course where we just learned the basic syntax of the basic things that you are already very familiar with in other languages, like loops, and of course we started with Hello World. So check it out if you're interested. I'm also sharing the GitHub link. What we usually do is we kind of sit down and push everything we learned together onto GitHub, so that way you get the latest things. Yesterday we realized a couple of things didn't work the way they do when we're using C purely and C in embedded systems. And yes, everyone learned something, including me. So let's get started in another minute. But until then, how are you all doing today? Do you all want to start by commenting the city you all are joining us from? That's awesome. I'm glad to know you all are doing awesome. Oh my god, you're joining us in Scorcher is joining in from Canada, and I can't believe you're still up. I mean, I've done streams last time at 4 a.m., 3 a.m. my time, but then I'm used to it. But I'm so glad you're here. We're going to read a data sheet together, Scorcher. I hope you enjoy it. But feel free to drop off whenever you want to. These recordings are available. Please do not compromise on your sleep. And yes, so I know Scorcher is joining us from Canada. Anyone else want to comment their cities where you're joining us from? All right, we have people from Katwa, then we have people from Delhi. All right, you all can meet up. You all are pretty close. Then we have people joining up from Kolkata. That's amazing. Mumbai, you're pretty close to me. And all right, we've got folks from all over India. That's nice. It makes sense. This is the IST time zone. I expect other folks from other countries to be asleep right now, including you, Scorcher. But I am so flattered that you're joining in, even though it's so late. Wow, we've got a lot of people from South as well. Awesome. So I'm joining in from Pune. So anyone close by, anyone in Pune, do drop us a hi. We're doing offline meetups now in my college, so you're welcome there. And we have someone from South Africa as well. Awesome. Let's see if y'all can see my stream. All right, this is session. Okay, we have Ashwin here as well. Ashwin is one of a veteran community members who's really active on most platforms. So I know for a fact if Ashwin joins in, a lot of people join in following him. So that's great, Ashwin. I'm so glad you're here. And awesome. So let's get started. Today is session 2 of the embedded systems. I'm going to do again a quick recap. We didn't do much, and we're not going to do much today either. They're supposed to be short, light sessions where you all can keep up, where you learn something new. So let's get dive right into it. And there we go. Okay. So moving on, what we usually do is intros and icebreakers. So I disagree. Ashwin has a lot of credentials much better than what I've said that are up there. So do check his profile out. He's a very active community member. Having said that, let's dive right into intros and icebreakers. So we've already done a tad bit of intros. I have a good idea of where you all are joining in from. I would love to, talk to you all in person as well. So if you see me in the Hacker Hangout in the next couple of weekends, do drop by. Since you all can't introduce yourself, but you all can have an icebreaker with me. So let's see if you all know how I usually run my streams. You all know that what we're going to do is we're going to ask the one question we're actually going to solve today through the PPT, which is today, what is a data sheet, and how important it is. So the first word that comes to your mind when you hear the word data sheet, I can imagine something. So the first thing that comes to my mind, at least what used to come to my mind, was this really drabby sheet with lots of statistics that I have no clue what's happening. So that's the first thing that used to come to my mind. Of course, my experience now is very different, having been through a lot of experiences that I would be sharing eventually. So, all right. So I have one answer: data sheet, Excel. That's great. Also, you're joining in from UK. I'm imagining even UK. It's pretty late. So, thank you so much for joining in. Uh, great answers. Excel sheet is a pretty good way to imagine it. It's basically a data sheet, right? What it says. But any more answers? What's the first word that comes to your mind when you hear the word data sheet? Is it? It can be anything really. I mean, last time I got some pretty creative answers when we spoke about embedded systems and IoT. And I think this is the exact reaction I was talking about when I used to hear the word data sheet first. So I'm assuming that's your answer. Pretty great. That's also a great answer. If you're laughing hearing the word data sheet, I totally get that too. But I'm assuming this is your reaction to your earlier answer. But yeah, you all have a pretty good understanding as to what we'll be doing, right? So, a data sheet is very important. I cannot stress enough on how many things can go wrong. How and I won't lie. Learning it the hard way has been fun. I have some pretty great anecdotes, but yes, it is also very dangerous, and it does speed up your process of development. It's a lot easier. You understand what's happening. Uh, the whole point of doing this exercise is to give you an intuition as to what you'll be learning. You're not supposed to know data sheet, else you wouldn't be here. So feel free to still put in your answer. Well, close enough, except it's not on any of the softwares. But yes, you all have a pretty good idea as to what we're dealing with, right? A data sheet is exactly what it sounds like, right? It's a sheet with a lot of data. Now that data has a couple of tables, it also has some statistics, and it also has lots of graphs. Now we're going a little further and further away, but yes, basically it's data arranged. It's not CSV files, absolutely not. But yes, again, data sheets very important. That is going to be the lesson for today. We'll also look into project setup and everything, which I know all of you all are going to manage. It's a cakewalk. If you have any trouble, it's usually because of the difference in OSs. So don't worry about that. We'll fix it. I'm available on Discord later if you all still have any trouble. So, all right. I am so glad you tried Dibdinak. So basically, it's a manual. That's a good answer as well. All right. Exactly. HK51712. That's exactly what we're going to be looking into data sheets, right? So let's move on. Let's move on and see what we're going to be doing today. So before we get started, in case you all are new to the stream, I'm Prithvi. I've been calling myself a new coach for the past 9 months. So I think I should stop doing that. I'm a fairly new coach, but old enough to know what's going on. I have a pretty extensive background in IoT and embedded systems because most of my learnings have been the hard way, which is me not going the right way, is why I'm here telling you that please do it the right way. It's a lot easier, it's a lot more fun. I love communities, which is why, again, I'm here. I love interacting with new hackers and yes, Ashwin, I think that's a good thing. We could actually start, a new petition for that because I think, yeah, but then I get it's been busy for MLH, so let's hope very soon I get in my MLH tune. But until then, here we are. And yes, so I'm a pretty passionate community builder. While I'm not very active on the social media platforms, I am pretty prompt with my responses on any of them. Uh, so yeah, feel free to connect with me on any of these platforms that are listed. I am happy to answer your questions. I'm also available on Discord. Feel free to create a ticket, tag me there, or just tag me in Discord and I'll get back to you. All right. Okay, moving on. Session 1 is done. We are on to session 2 today, which is this. So we will look into what is a data sheet. We'll actually sit down together and read a data sheet together, which is basically go through every statistic. If you all want to understand more, we have another data sheet also which we can go through, but I think one should be good enough for us. That's the main thing that we're going to be doing today. Then we'll also focus on installation and project setups. There are multiple ways to go about it, so I'll show you the easiest way because I was actually going to do it the hard way with you all, but then one of the hackers in my last session pointed out asked for an IDE, and I realized that all of you all could benefit using the same IDE. So we're going to be doing that. And then we'll do a very brief intro into RDS concepts. I'll throw a lot of terms at you all. Don't worry, there are no slides to it. You just need to listen. Once you're comfortable with the terms, the next session, when we actually start coding and scheduling and, actually using the terms, you'll get very comfortable. All right, and then we're going to have Q&A where we will just have some chill conversation. If you all want to stick around, if you all want to join the stream and ask questions, I'll be happy to have you all on it. And yeah, then next steps will be me pushing everything we did today, including the links onto GitHub right here, and you all will be able to access it. Sounds good? All right, let's move on to the next slide. All right. Burning question of the day. What is a data sheet? All of you all were very correct in everything that you answered. Yes, it's a sheet with a lot of data. Yes, it's basically your Excel and Google sheet, but basically all that data concised into smaller formats. Because a data sheet, so any component that you end up Googling, right, from your Arduino to your ICs to your modules, everything has a data sheet, which is basically a manual, but a rather high level manual, because the data sheet won't tell you that, okay, connect this to this or use this way. It's literally just telling, it's like a biodata or a LinkedIn profile, if you may, of a component, right? It's going to tell you this is the work it's done, this is the work it can do. You can push it to the potential, but this is the point it'll probably break, right? It's going to tell you all the certifications it's been through, be it environmental based or if there are some temperature certifications that it's been through. So it's literally your components profile, LinkedIn profile. To an extent, it's also a modeling profile because you also have every angle that the IC or the module can look like, right? So you have its footprint, you have its all its diagrams. So that's basically what a data sheet is. It's a very high level manual in which you can just know everything there is to about the IC, how to make sense of it. They're going to list out a lot of things. Why are they important? How do you really consider them, and why do you even bother with it, is what we're going to do when we start reading a data sheet. All right, so here's what we're going to do next. I'm going to drop a link to a data sheet that we'll be going through. All right, first, y'all, I'm going to give you exactly 2 minutes to open the data sheet. Just rummage through it and see if any word pops out to you. If anything makes perfect sense to you or does not make sense to you at all. All right, once you all do that, and if any one of you wants to come onto the stream and maybe try your hand at it, you're welcome to do so. See if you can understand what the data sheet is trying to say. All right, I have my Discord open, so if you all create a quick ticket and tag me there, I'll make sure that you'll get a stream link. But that's what we're going to do. We're going to give you around 2 to 3 minutes to rummage through the data sheet. I promise I'll stop talking, and once we do that, we'll come on stream and actually read the data sheet together. All right, so let me quickly drop the data sheet. Also, I just saw that one of y'all asked me for my profile links, so I'll send that as well. And I just realized that I'll have to send you a different link because I have it downloaded. So let me quickly go into. All right. Great. I cannot share this link, so okay, let me find the right link for y'all. Uh, so in case y'all aren't sure, what you can do is you can Google for LM555 datasheet. Give me 1 second. Let me see if I can find. No. Okay, I found the right link. So let me quickly drop the link in. There you go. Alright, so I've dropped the link in the chat. Feel free to open it, damage through it at your pace, really. No rush. If you all want me to wait even after the 4 minutes that I give you, we can do that. It's 3:52 at my end. So let's give you all until 3:56 to just rummage through it. Take your time. You want to Google some words up, go ahead, do that. And while you're at it, I'm gonna go off stream for 4 minutes. I'm available on the chat though, so that I can shut up for a bit till you all read the data sheet. And I'll also drop my profile links in case you all want to talk to me there. Also, to answer this quick question, I am usually available on the weekends and staffing when you tag me at active MLHers. It's usually against the Discord rules to tag me directly an MLHer. But if you're creating a ticket today, feel free to tag me for the next hour, and I'll make sure you all get the stream link, or you all can know what my ID is. All right. Okay, I'll share the link again, and I'm gonna go off stream for the next 4 minutes. All right, I see that some of you are ready to move on, so we'll do just that. And all right, so one of us explained what DS or data sheet earlier is doing, and you all are correct. Yes, a data sheet is basically explaining in detail the components of usage of, in this case, LM555, because that's what we're going to be dealing with, right? Let me quickly share my screen and show you how exactly, how detailed and what exactly is the data sheet really showing. Right, give me 1 second. All right, so can you all see the screen? Let me increase the size. Awesome. All right, I hope you all can read. If not, I'll be happy to take myself off the make it full screen basically. And but yeah, that's okay. Let me know if you all want me to go full screen with the presentation. That way, you'll be able to see it better. If not, we'll figure out another way to share. This is a nice sheet that I actually found. This was actually made during Women in Tech outreach program. So I'll share this link, this commented link that's available on the internet. I'll be adding it to GitHub and pushing it today, but make sure that the source you know is not mine. All right. Great. So let's get started. Okay. So first things first, right? Some small details that you usually might miss out the first time you're looking at is the date, right? So it's very important to look at the date. Why why do you think the date is important? Well, because a lot of times there are multiple modules and multiple versions that have come out, especially if you're googling for the data sheet. There's a high chance you want to verify whether the date is correct, whether the version of the document is correct. There will be version written if there are different versions of it. A quick example would be, I was working with SI1147. It's kind of an obsolete module. It's not used a lot in applications anymore, according to my understanding. But yes, it had like three different versions, and then one version had like great application notes, the other two didn't. And if there was a very high chance, obviously, to stumble on the ones that did not have the application notes. So you struggle a lot when you don't understand what's going on. So small things like date and preliminary information and versions, right? Make sure that you all always have a look at this. All right. Next, features, right? So like we mentioned, right, this is basically your chip's LinkedIn profile. It's going to tell you everything that it needs. First, it's going to tell you the general description, right? So what does it do, what is the basic purpose, and if there is anything special about that chip. For example, if it's a new chip that is low power and can connect to some kind of a radio protocol rather easily, that's going to be the highlight here. All right, we look at a couple of other open source data sheets and see what changes in the general description. Why? Because we can then look out for what we need to look out in the general description to be aware in terms of why that chip is special. Okay, why was there need for it to exist in the first place, right? So all right, let's look at this, right? So the what's the main feature that they're telling you, right? This is the main feature according to them, right? According to the makers, they're saying that it can exist in multiple modes, and in a certain mode it is capable of doing certain things. All right. This is your main line. It's a highly stable device for generating time delays and oscillation. All right, so that's your main feature. Right. Let's go on to the features that they've listed. Right. This is again. This is where you'll come to know again if there is any exception of any sort, and this can be very important again. Your exceptions will what will define all the time your code does not work on the device, right? So it replaces this, the LM3 555, Okay, why does it need to replace it? You can always look. So that's the first question that needs to come to your head. Why is it replacing it? That means there was something in the NE555 that was either not working or it has gone obsolete for certain reasons. It could be the material requirement, it could be anything, right? This is another very important feature, timing through microseconds through hours. Why is this important? Because this is supposed to be an oscillation generating device. So this is where you'll come to know the big limit of what it's capable of doing, right? You all can either select or rather, reject the chip by just reading this much, and know if your application fits the bill, right? If the chip fits the bill of your application, rather, right? So it has an adjustable duty cycle, and so this is basically all the features that can help you very vaguely understand if the chip is capable of doing the work that you want it to do. All right. Next, we have the applications. This again will give you a very good idea as to what your chip is capable of doing outside the description. Let's say you don't understand this, right? Let's say you don't know what's a duty cycle, or you don't want to know whether your application is going to read this much current. This will tell you whether or not your chip can handle your application. All right. Now, this is the schematic design. It's not very important if you're not building something product wise, if you're just trying to understand, because then you have to understand the transistors and everything. But this is very good in case you're building a product from ground up and you want to debug it right to the level, and especially if you're building a custom PCB, right? This is very important. Otherwise, all you need to pay attention to are these pins. These pins are what you finally end up connecting to, and that's the main highlight of this entire diagram for you. All right. Okay. So this is called the equivalent schematic design. This schematic design isn't what is necessarily in the device, but the device acts if this was what was inside. What does that mean? That this is not the exact schematic. All right. So that's a very important note for you all to take. All right. It can help explain the behavior, but it is not, again, just an understanding to give you the best understanding possible to understand what would happen. All right. Next is the connection diagram. This is what is very important. All right. Understanding the connection diagram, and the note couldn't be more specific in terms, or rather more accurate. Make sure you're looking at the pinout for the correct package. All right. What do you mean by package? So I don't know if you have seen multiple microcontrollers, or if you've seen different just different chipsets, right? You'll see that there are sometimes registers that are small, sometimes that are big, sometimes they're more 3D, sometimes they're more flat. So basically those are different packages. For chips it's even more different. If you've seen two Arduinos, there's one Arduino with a square chip, and then there's another one with a more 3D-ish chip that kind of stands out, right? Your normal package. So those are different types of packages. Each package has a name. The 3D-ish package is called a DIB package, which is basically a dual inline package. So dual inline package, right? I should have had my chips outside. I'll see if I can grab something right here very quickly. Oh, I can't. But basically, you all get the point, right? So a dual inline package is what is sometimes used, or rather mostly used, in prototyping. Then there is the QFN package, which is your flat package, the tiny, very sophisticated ones that you see on your microcontrollers, or rather even if you've ever opened a device, any of your sophisticated device, there are flatter chips, right? They're either called surface mount device packaging, or QFN packages. So SMD is the package you want to find in your resistor, capacitor, and components if you want the flatter, thinner version, and QFN for your chips. All right, and there are more packages, right? So you can see, right? These are the packages. This is a DIB package, and you have the SOIC package, right? And these are the names that you'll find it for. Why are we saying that this is important? Because remember, if the size and shape is changing, of course the pin number and the pin location is going to change. All right. So always be very mindful of this. You can be working with one package for the longest time, and suddenly when you switch packages, you might not remember, which is why having a data sheet in front of you is very important. All right. Okay, so these are some extra notes for ordering, and keeping in mind that when the package changes, there is a pretty good chance that the temperature considerations could change. Either they could become wider or they could become lower, depending on what end you're using or what end you're moving to for the package. All right. Okay, now comes the more technical part and the more important part. All right. So maximum ratings. And why are maximum ratings important? Of course, right? You want to make sure that you don't burn your chip, or your chip at least starts working. Now, these are of course very extreme conditions and you'll probably never reach them, but from a product point of view, it's always good to know. What you need to really know is what's highlighted in yellow here: the supply voltage, that is 18 volts for this one, and the power dissipation, right? Why is the power dissipation important? Because remember, your power rating calculation comes from your voltage and current, and that way you know how much you can kind of play around with the voltage versus current scenario to make sure that the power dissipation is less than what is happening or what is mentioned here. Otherwise, regardless of your temperature, your chip will heat up, right? So the easiest way to blow up a chip is to connect voltage and your ground to the reverse side, right? That what happens is your diode heats up, and as soon as your diode breaks, there's a current. So either your diode can heat up the chip, or if the diode survives and your chip is safe, great. If not, what will happen is your diode will blow up and the reverse current will blow your chip up. All right. Now, when I say blow your chip up, it means that it's not blowing up. It's just simply going to stop working. You might see a little bit of smoke. While it's not dangerous if you're working with smaller chips, it is something that is very easily avoidable. So do that. All right. Absolutely, Manish. I'll be sharing this PDF. I'll be pushing it onto GitHub right after this session. All right. Any other questions that I can take up before we move on? Haha. See, I can, and I'm sure, when you're telling me this, you know that had you read something more easily, you could have totally avoided it. So, see, breaking IC pens is okay. Blowing up ICs is not okay. All right. So, if you can avoid it, and it is very easy to avoid it by reading the data sheet thoroughly. So, let's do that. All right. Okay. Moving on. Right. Okay, this is again very important. This is where your input and output characteristics comes in, and this is how you start with the testing of the chip, right? So here's how it works in a normal production where or a production, house, or if you're working on a product that's eventually going to get produced. When you're testing a chip, you're going to first verify at least the limits that you wanted. If it's going to be an extreme application, you're going to verify what the data sheet is saying. But if it's going to be something that is not going to go to the limits, what you are going to verify are the limits of your application. Let's say you know that your application is going to use so and so voltage, it's going to go up to so much so current. You want to make sure you put it on the chip uh, via either your bench bench power supplies, or you can also go and do it on a simulator, but it's usually good when you have a hardware chip to verify it against the data sheet. All right. So quick note over here, right? You see all these numbers mentioned here. You will see they say there's a lot of technical terms, right? One of the people that I follow on embedded systems, and their blogs are pretty great on this. They mention very clearly, okay, there are three thumb rules of doing your work in this field. I would say, I don't know if field is the right word, but basically working with electronics is read the data sheet. All right, that's the first rule. The second rule is also read the data sheet. The third rule is do not trust the data sheet. Why? Because remember, these limits are for only the chip alone. When you're connecting it to a bigger network, there are multiple more factors that are coming in. One of the biggest factors that I have seen, really influence our entire circuit is an EMF. All right, if you're working with motors, there is an EMF that's generated, and even without or with a diode, there is a lot of influence on the rest of the circuit board. All right, so when you start with these limits, but remember, you need to make sure that you verify them, which is why the verification process is very important. All right, so now the electrical characteristics continue. Okay, very important note as to why these electrical specifications are very important if you're working with a microcontroller. Let's say this data sheet was for a sensor or a motor or any other actuator that you're using, right? if you don't understand these limits, right, the power or the voltage at which the device starts and ends, and if you connect it to the microcontroller directly, your microcontroller has its own working voltage, right? Some of them work at 3.3 volts, some work at 5 volts. And if you connect a 3.3 volt component to a 5 volt component and its limit does not support 5 volts, there is a very high chance it's going to break down. Fair? And then if you connect a 5 volt component to a 3 volt component, it's obviously not going to work. And I've done both the mistakes, which is again why I'm telling you data sheets are very important to understand the component. Reading a data sheet a couple of times before you start the project is a very good idea. All right. Then there are a couple of other voltages to note. Is if you're working with the microcontrollers, these aren't very important until you put them in a real PCB. But knowing that this could cause a breakdown or could be the reason why your code is not working is very important. All right. So output voltage is again very important because that's what you're connecting to your next component in the circuit, and that next component in the circuit should be able to take these output voltages. All right. They also give a lot of notes. All right. So this is again a very important note. So I'm going to give you exactly a minute to read this. If you all can't see, let me increase the font size. Exactly. I think I'm not sure if I've given this example before, but I've done this. I've connected a 5 volt server to a Raspberry Pi and reworked my code almost 8 times before realizing that the problem wasn't in my code, but rather the Pi needed that amount of voltage. So the Pi does have one 5 volt output. But remember, a server, if it has a V out and an output signal, it needs both the signals to be around 5 volts. So your small servers work, but more than that, there's a very high chance they're not going to work with your Pi. Alright? So I'm hoping you all can read this. If not, I'm going to quickly remove myself from the stream. Or rather go full screen. There you go. Alright. Okay. Moving on. Okay, he's given it in bigger words as well, which is very sweet. So let me do this. Alright. Moving on. Back to uh, back to our data sheet graphs. Okay, very important. Why are these important? Because these tell you whether or not uh, your signal can detect multiple magnitudes. Okay, so again, this is an LM 555 module. So this is not that important for this one. But if you are using a sensor module, or if you're using something that either gives a signal or receives a signal, which is either digital or analog, this is the point where you'll know how sensitive it is to signals. For example, right, if you all know how digital signals work, right, you have a 0 and a 1, but your microcontroller does not give a 0 or a 1, right? It either gives, how does it know it's a 0 or a 1? What it does is, let's say it's a 3.3 volts microcontroller signal, it's going to divide 3.3 volts into half. So that would be what? Anyone? 3.3 is half 1.35, I think. Let's see. 1.65. All right. So 1.65 is what your signal is going to be for 1. I think it's 1.65. But okay, it's going to be, so the upper half is what's going to be treated as 1, and what the lower half is going to be treated as 0. So it's never going to give you a 0 or a 3.3 volts. That's the ideal condition. But anything above the more than half is going to be treated as 1. Anything below half is going to be treated as 0. Now this graph in your module or your sensor will be able to tell you how sensitive it is. Because if it is not very sensitive, you can have a little bit of bad wiring might not hurt the signal, but of course bad wiring is never appreciated, right? But if you have good wiring, and if it is very sensitive, even then if it receives a tad bit of a signal and it goes up and down, it's going to be able to sense a 0 or a 1, and hence switch, especially if it's an input pin. All right. So that is why these graphs are important. All right. Let's see. Okay, now again, so this is fine. This is all okay. This is specific again to LM35, LM555. Uh, what this is saying is the application usages. Now remember, it's not telling you how to connect it in every way. It's just telling you that this is one mode, this is the second mode, and this is the third mode. You need to sit and see. It's going to also give you the calculations. So after this, if you want to make something, let's say if you want to build it in monostable mode with a particular output, you're going to have to sit and back calculate all of these. All right, now these waveforms are to kind of again help you verify the application. They're telling you that if you build it in this mode and when you connect the output, when we are giving so and so input and so clock, we're getting this output. So this is very important for verification point of view. Okay, physical dimensions. Why are physical dimensions important? So remember, I told you this is also a modeling profile. So this is the part of the data sheet where you will verify whether it fits the size of your application. If your PCB is so and so size, and if you have multiple options available, whether this package, whether this chip at all fits your application. It will also tell you the dimensions in terms of the pin size, the distance between two pins, both laterally and vertically. It will also tell you what is the one, where the one starts. All right, so that is it. That is the end of this data sheet. So let's go back to our PowerPoint. And before we do though, so any questions uh, regarding what we just read through? If you want, we can also do a module reading very quickly. We can read an accelerometer's data sheet. I will give you 1 minute to tell me if you all want to go through accelerometer's data sheet also. That way you'll understand why the module and everything changes there. So data sheets again, very important. Cannot stress enough how important they are, especially if you're working. Another reason why data sheets are very important is if you're working with something for the first time. Let's say you're working with a new embedded systems project, and you take up a sensor, and the library does not exist. How would you go about writing your own library? How do you know? So if you all have used Arduino, you all use a very abstracted version of the code, right? You all are doing digital write, or your module.get data. It's not that easy, right? And on the if you look into the libraries and go deeper into the libraries, you'll realize that there's every register that's being read. Every register needs to be given time to be read and to send the data. There is a particular code that needs to be sent to read the data. All right, so make sure that data sheet. So what I'll do is I'll drop the data sheet to what I would have read, and what I will do is I will send you another tutorial related to the same, so that way you all can keep up. All right, so let's quickly send you the data sheet. I'll send you the data sheet, and what we will do is when I push the code, I'll also push the tutorial link to that data sheet. That way it'll be easier for you all to understand what I mean. Okay. So datasheet module may you will understand why a particular register exists and what that register is doing in that module. All right. So let's go back to our PPT. All right. We've read a data sheet, and now let's set up your project. All right. So we are going to be using platform.io. We are going to set up platform.io. So I am sending you all the link to set it up. I am using VS Code. You all are welcome to use any of the other options available. I Let me check what all options are available. So you have platform IO IDE independently as well. There's also command line tool, and you have it for Atom, and oh, you have it for a lot of other. You have it for Eclipse. You have it for Code Blocks, Emacs, NetBeans, Qt Creator. So yeah, you have lots of options. So feel free to install it for whatever platform you usually use, right? And Okay, so I'm going to stop sharing my screen again and I'll start sharing my VS Code so that we can see how it entirely looks once I am done installing. Alright. So if you're done installing, this is the screen that will pop up in your VS Code. Alright. This is the home that should pop up. Alright. Installing it is fairly easy. Let me know if you all face any trouble installing. If you all want me to send any tutorials your way or any GIFs that help you install it better, let me know. But this is where you'll be at once you do install it. Alright. So I can see a notification here and there's an update. So let me try and update what it is. But apart from that, you all can go into the installations and install the different device chipsets that you want. So I usually use Nordic and RF52 and Atmel Mega AVR. This is basically your Arduino controller and this is what I used with my microbit. Alright. You all can also look at the different options available, play around with it. There are tons of libraries. You all can also use Arduino IDE from right here. Alright, so you can see you all can import an Arduino project, and there are some beautiful tutorials available on this as well. So I am going to give another minute for you all to see if you all are comfortable installing. If not, I'll help you out there. If you all are comfortable installing, I'll go through the Zephyr installation page and tell you a couple of things that you want to keep in mind when you're installing Zephyr independently. I would ideally ask you all to use Zephyr independently because the setup itself is a tad bit complicated, but I know for a fact that you always keep up. Alright, once you're through with that, so what we'll do today is also set up an entire project for ourselves in which we'll continue coding. So if you all can follow along and quickly install it, that'll be great. Okay, yes, you all wanted my profiles. Let me share all my profiles together. That will be a little easier for you all as well. So, all right. I'm first dropping the link to Zephyr. You all can start going through the Zephyr documentation. It's a beautiful documentation. It really explains how the device tree structure and everything works. Uh, Next, I will share. I'm gonna give. Please let me know if you all are trying to install platform.io and face any issue installing it. I'm dropping all my links in the chat at the same time, and I see there's some error someone's given. All right, when are you getting this error? I would love for you to show me the screen right now, but let me see if I can quickly get you on stream. So, G00 brick, where are you facing the trouble exactly? When while installing or Okay, what command did you try executing? Do you want me to look at the documentation ones very quickly? Okay. Are you trying to install platform.io for your command line? Is that what you're trying to do? All right, let me quickly look. So, are you trying to install it? Okay, you're installing for your command line. Let me see if I can help you there. So, I am pretty sure I haven't installed it for my command line. So, I think this should be a good way to debug this. You are on Windows, correct? Awesome. Thank you very much for confirming. Let me quickly look into that. Command line. Hmm. And what method are you using? Okay, Debian Linux. All right, I'll look into that then. Also, for the people who wanted to run C code yesterday and had any trouble with GCC, quick note: y'all can also use WSL if y'all want to run GCC right out of the box. I have tried and tested it yesterday so that it's easy for y'all. So, in case y'all want to know how to do that, I'll be running a Definitely workshop on I think Thursday or Friday. I'll let you know the exact date, but on that day we'll be using WSL for Definity on Windows because otherwise it does not run. So if you all want to tune in and understand how to use a WSL, that's a good opportunity for you all to do that. All right, and let me quickly Debian Linux. Okay, and for that, are you using method one or method two? Awesome, it worked. Great. If you still want us to debug in the second method, we're happy to do that. All right. Alright, so next let's look at the Zephyr page so that you all can understand how to go about installing that as well. Alright, so this is the Zephyr documentation page. This is what we'll be using to understand how to work with Zephyr. So let's look at installation directly. I would very much encourage you all to go through this. So let's go to the getting started guide. And this is the installation process. All right, so I usually follow the Windows one, of course, but you all can follow whatever OS makes sense to you. Okay, I've done it on Ubuntu as well, so if you all get stuck anywhere, let me know. I'm happy to help you. All right, this is a slightly tricky part. Also, it is going to ask you to install PowerShell. PowerShell is already installed. Do not install it again. So you need to just, it's a pretty simple thing. Quite honestly, it's not that difficult. Let me quickly show my command line and tell you how it should look like once it starts running. So let me see if it actually works. So if it works, it should look something like this on the command line. So of course so if you all can see my command line, this is what it should look like. So the fact that it started the West build means that my Zephyr is running. I haven't specified my board here. All right. So this is the command that I was supposed to follow. It won't be able to find CMake because there is no board name here. All right. But if you have West and everything installed, this is what it will try and do. If you can see this, that means you have everything installed correctly. All right. So Please do set up your installations. Let me quickly again go back to my VS Code and show you how we'll be setting up our project. So let's just set up the basics. Once you install everything, this is what it should look like. Is anyone having any trouble installing? All right. It's not letting me share my screen. Fun, fun. All right, there we go. So this is where we're at again. So let's try and create a new project. All right. So we'll create a new project, and we will set it up. All right. So our project name is going to be GHW test. Then we're going to select a board. Now, if you have a certain board, do give that a select. What I am going to be selecting is a microbit. So, all right, let's. I might have to install it again. BBC. Yep, there you go. So this is what I'm going to be using. But if you all have any other controller that you all prefer using, or if you all want me to do a separate version for that, do let me know. What we will be using is Zephyr OS. Okay, use default location, finish. That's fine. All right. So this is a nice way if you have installed platform.io. You all can just go for this. What it will do is it will install everything on the backend. But I want you all to understand how Zephyr installation works, because that way you'll have access to the Zephyr files directly. So do and try and use install Zephyr directly. All right. But while this happens, are there any questions as to how to use this, or what would you like to know in particular right now? Anything that we covered today? Anyone following side by side? We'll start writing code in the same project. Yes, yes, I should have taken this stream in Jan, right? It's okay, Ashwin. Now you can come on the stream today or next time and share your anecdotes as to why you would have wanted data sheets earlier. All right. Anyone with any other questions? If not, what we will do is I'll take 5 more minutes of Q&A if there are any. If not, I'll end the stream. And in the next stream, if you all get to the point where I am at right now, where you have your project set up, we'll start writing code in this project. And uh, what I am going to do is I'm going to throw a lot of RTOS concepts at you. That way, it won't just be concepts. We'll actually understand why a task works in a certain way, or why scheduling is done the way it is, and why people make such a big deal out of it, or you know some more terms as to why is RTOS really there. I mean, so you'll understand when we look into the hardware board files, you realize only like 6% of the code is actually used to communicate with the hardware. The rest of the code is basically same for every board that you write. Why is that the way it is, and why is it still so necessary? So that's 6% of lines. So basically every RTS of yours that exists, there's only a tiny part of it that's actually communicating with the hardware, but that tiny part is what makes all the difference. All right. So again, I'm gonna wait for another 5 minutes if there are any questions. If not, I'm happy to close the stream for today, and I'll see you all in the next stream. Thank you, Utsav. I really appreciate at least someone. I hope you all are actually learning something. I feel the thing is, last time I took and I got lots of questions regarding the basics, and I wanted to kind of make sure it's very beginner friendly this time. So I understand if you all aren't very happy with the amount of content that's being delivered, but I'm kind of still playing around with how I do the content partition. So I'm really happy if you all have any feedback regarding this. If you want me to be faster, if you want me to cover things in further detail, talk more about the technical stuff, or make it more generic. I am happy to go either way, because last time I remember getting a lot of feedback regarding it being either too in depth and too fast. So this time I'm trying to kind of play around with the type of content I'm delivering. So do let me know. All right. What I'm going to do is I'm going to close the stream for today then, and we'll actually write RTOS code next time. So please, if you all can come up to this step, that'll be great, because I would really want you all to follow along while we do this. Again, once you have platform.io set up, it's very simple. It does all the backend installation for you. So that shouldn't be a problem. But again, if there are any questions, feel free to reach out to me via Discord or any of the platforms that I shared earlier. All right. Well, thank you so much, folks, again for joining in. Thank you, Ashwin, Utsav, and I hope Scorcher left and slept. It was pretty late for him, and G00 Brick. Actually, I'm doing more than 7 streams this time, so you'll see me in a couple of mini events also coming up. I'm pretty excited for my Art Plus Technology mini event that I do, so I really hope you all can make it. If you all want to know the materials beforehand and follow along with me, I'm happy to share that with you as well. But yeah, all right, you'll be seeing a lot of me this week, so yeah, if you have any questions, feel free to pop in to any other stream and throw them my way. All right. Bye, all. This was really fun for me. I hope you all had some fun too.